I'm Anil Kumar, and now let us begin to understand what is derivative of a function. We'll start with a very basic definition. The question here is, explain the significance of the expression limit h approaches 0 for f of a plus h minus fa over h. Now, as you know, we have used this equation to find the limits, and there are two very important applications using this particular limit. One of them is to find slope of a tangent to the graph. So one of them, let me write down here, is slope of tangent line to the graph of f of x at a specific point x equals to a. So that is one importance of this particular expression, and the other one is we can find instantaneous rate of change. On any function, right, we can say instantaneous rate of change of a function f of x. We can write y equals to f of x with respect to x, the independent variable, at x equals to a, right? So these are two very important applications of this particular expression. So these are the two ways we have used this expression in the previous chapter. So this expression gives us two things, slope and instantaneous rate of change. Now it has such a wide application that we have given it a name, and that name is derivative. So from now onwards we'll use the same definition and we'll say derivative at any point x equals to a on the graph of the function is given by that. So, and it has been written as f dash of x is equals to limit h approaches 0 for f of a plus h minus fa divided by h, right? So that is how we are going to use this particular expression from now onwards, right? So basically, what is derivative? Whenever we find a derivative at a point, the point should exist on the graph, and it is actually slope of the tangent line at that particular point, right? So the derivative gives us these two things, which are kind of same. Slope of tangent line to the graph of f of x at x equals to a, or it may give you instantaneous rate of change of a function y equals to f of x with respect to x at x equals to a. So when we go for the second definition, at times we also write this as dy over dx, right? So dy over dx will sometimes be used instead of f dash x, since it is instantaneous rate of change of y. So that is dy, rate of change of y with respect to x, that is dx, right? So in a way, the way we saw it like this, delta y over delta x, where delta x approaches 0, right? So limit delta x approaches 0. So this particular definition could be written as dy over dx, where we are using the nomenclature f dash x. So let's begin with derivative of functions, and we'll use the same expression, limit h approaches 0, f of a plus h minus fa over h, to find the derivative at any point x equals to a on the graph of the function, right? And this derivative will give us the slope of the tangent line or the instantaneous rate of change at that point. So that is how it has to be interpreted. Okay, so let's begin with this. Thank you and all the best.